In this video, we're going to go through section 2.2, which is on trigonometric functions of non-acute angles. And you might be a little confused in that you might be wondering, well, didn't we already talk about trig functions of non-acute angles in these sections in chapter 1 where we talked about the general definition of trig functions? You know, in the previous section, section 2.1, that was trig functions of acute angles, but we were kind of focusing on actual right triangles in that section. Well, non-acute angles aren't present in right triangles, so the way I would look at it for now, as we're making our way through chapter 2, just think about it like in chapter 2, we're looking at the definition of trig functions from different perspectives. We're kind of focusing in on acute angles in the previous section, and here we're going to focus in a little more on non-acute angles. And then by the end of chapter 2, we'll be done officially like defining trig functions and looking at the definition from different perspectives. And so what I think I'll do is at the end of chapter 2, I'll make another video that just gives an overview of everything that we did and the purpose of all of these sections. Okay, but for now, let's just take a closer look at trig functions of non-acute angles. All right, so when you're thinking about trig functions of non-acute angles, you're going to think about reference angles. So what are reference angles? Well, from chapter 1, from everything we talked about in chapter 1, you're familiar with what a reference angle is. I just never explicitly told you that it was a reference angle. So if we think about the general definition of trig functions, so it's measured, the initial side is along the positive x-axis, and then you draw the terminal side based on the angle you're wanting to find the trig function of. So let's say we're wanting to find the trig function of this angle, whatever this is. Okay, so we'll put a ray here. Okay, so this angle. What are the trig functions of this angle? The reference angle is just the angle that the terminal side, in whatever quadrant it is, the angle that side makes with the horizontal axis. So in this case, this would be the reference angle. And the reference angle is not theta, but theta prime. Now, I mentioned that you were already familiar with this angle. What did I mean by that? Well, if we continue with the general definition, so that the next step would be you pick a point along this line, any point, and then you make a right triangle where the perpendicular is attached to the horizontal. Then you put the side lengths. So this is R, this is Y, this is X. But you keep in mind that this is like, in this case, this would be negative Y, this would be negative X. And then I mentioned that you come to this angle within the right triangle whose vertex is the origin, and you do SOHCAHTOA. Well, that angle, that's the reference angle. If you draw this setup in any quadrant, that angle is the reference angle. Okay, now note that the reference angles are always positive and are between 0 and 90 degrees. So they're acute. So it's a little tricky. Like, you want to imagine that. So anytime you construct a right triangle like this in any quadrant, well, the angles of the right triangle aren't going to be negative, right? And then these angles aren't going to be, they're going to be acute. So think about that. The reference angle is always a positive angle because you have a right triangle here. But the problem with that is it's a little confusing because then, you know, triangles can't have negative side lengths, right? But with this general definition, they can. So it's just something you have to memorize, that the reference angle is never negative. It's always positive and acute. Okay, now some other things to note are that, so if you've got coterminal angles, so this angle plus 360 or minus 360, coterminal angles have the same reference angle, which makes sense. Okay, what else? If you have an acute angle, so if you're thinking about, you know, this angle, then that angle and its reference angle are the same. Any acute angle has a reference angle that's the same as the angle itself. Now, don't get confused, though, if you've got something like 375 degrees. Okay, there's like 375, so that's like 15 degrees past, this is 15 degrees. Don't think that, okay, well, that's 375. That's like an acute angle. Yeah, it is, but, well, technically it's not, right? 375 is technically not an acute angle. It's not between 0 and 90, but like it's kind of like an acute angle, but the angle 375 has a reference angle of 15 degrees, but that's not the same as its reference angle. Okay, so you see the difference? Note that. What else? Now, another thing to note is that quadrantal angles don't have reference angles. And the reason is because, well, you can think about it. So if you have like theta is equal to 90, well, what's its reference angle? Is it this direction or this direction? But reference angles are positive, and they're between 0 and 90. Well, 90 degrees is not between 0 and 90, so it violates this property of reference angles. So yeah, but quadrantal angles don't have reference angles. Okay. Now, so what are we going to do with these reference angles? What's the purpose? Well, okay, yeah, if we've already got side length information like we did in chapter 1, then there's no real purpose of the reference angle, because you don't need to know what this angle is. You just come to this angle of the right triangle in whatever quadrant and do SOHCAHTOA. But I mean, you can look at it from another perspective. If the reference angle was 30 degrees, and in this section, actually, the example problems we're gonna work with reference angles that are one of the special angles. So if you've got a reference angle that's one of the special angles, say 30 degrees, then what can you do? Well, you can then just take the sine of 30 or the cosine of 30 or whatever, get that value, and that trig function value is always going to be positive, because trig function values are always positive for acute angles, right? And then just do the analysis on the quadrant you're in to figure out what that trig function value, the sine of that value, should be. And then just apply the sine and you're done, right? Or you could think about, maybe you don't have the side length information, right? But if you find out that the reference angle is 30 degrees or 45 degrees or 60 degrees, then you can go to that triangle and put in the side lengths and put, so if this was 30 degrees, you would have, it would be, so x would be minus root 3, y would be minus 1, and r would be 2. And you might say, well, how do we know, what if the radius was something different than 2? It's all the proportions, right? It doesn't, you can pick any radius you want. So you just, if you know this is 30 degrees, we'll just put the radius to be 2. You can pick whatever you want. So if the radius is 2 and this is a 30, 60, 90 triangle, then that means this would be 1 and this would be root 3, but you put the signs. So the reference angle can help you if you don't have side lengths for the triangles. The reference angle can help you with that. If you've already got the side lengths, like for most of the problems we did in chapter 1, well then, it doesn't matter what we didn't care what the reference angle was. We just came to the reference angle and did the SOHCAHTOA on the reference angle, honoring the signs of the potential negative signs. Now, if you think about it, though, up to this point, the only angles that we could actually get side lengths for with no other information are the special angles, 30, 45, and 60. And this is something that we're going to talk about more in detail in upcoming sections. But, okay, if we take a look here, here's some different reference angles. You see it's the angle between the terminal side that defines the angle and the horizontal, and they always put it in the positive direction, counterclockwise. And it's always acute. And it's between the terminal side and the horizontal. That's what they're cautioning here. Never the vertical. It's always in the horizontal. And that comes from the fact that there's a hard rule in the general definition that you make the right triangle with the perpendicular of the horizontal, attached to the horizontal. No matter what quadrant you're in, you do that. And that rule helps to make sure that this is the case, that the reference angle is always, it's measured to the horizontal axis. Okay, find the reference angle for each angle. So 218 would be what? Well, you get to 180, and then how far past 180 do you go to get to 218? 38? Yeah. 180 plus 38 is 218. So the reference angle is just positive 38. What about 1387? Well, okay, how many revolutions? Let's divide 1387 by 360. So you go around 3 times. So 3 times 360 is 1080. Okay, and then we get to 1387, 307. Okay. So what is the angle that the terminal side of 307 makes with the x-axis, the horizontal axis? Not the positive x-axis, nothing like that. Just the x-axis. It's an acute angle. So you get to 307. You're coming around. You get to 270, 307. But then we're really looking for is what's 360 minus 307. Not how far from 270 to get to 307, but how far from 307 to get to 360. $53 degrees. Okay, the preceding example suggests, this is just like a summary of everything we just talked about. Okay, so special angles as reference angles. We can now find exact trigonometric function values of angles. Yeah, so if we can now find exact trigonometric function values of angles with these reference angles. That's any of these 3 angles or any of these angles with those reference angles. So what are they talking about here? What they're saying is that with no context, we just have theta is equal to, we're given an angle. That's it. Find the trigonometric function values. You might be saying, well, didn't we already do this before? No, we never really did this. We always had like additional information, like we had side length information, etc. We were just learning the definition of trig function values, but we never actually like started with just an angle and that's it. And then found the trigonometric function values. And you know, in upcoming videos, I'm going to expand on this more. I'm going to explain this in more detail what I mean here. But since we were able to apply geometric principles to actually get to find these trig function values explicitly, right? So we know like 30 degrees. So if this is 30, 60, we know sine of 30 is 1/2, cosine of 60 is 1/2, sine of 60 is √3/2, etc. And so with that, like we talked about, we can obviously get these trig function values for 30 and 60 and 45, but also we just talked about how if we have any angle that has reference angle 30, 60, or 45, well then we just talked about how to do that, how to get those exact trig function values, or even any angle that's coterminal with like 135 degrees, its reference angle is 45 degrees. Well, any angle that's coterminal with 135, we can find its trig function value. And why is that? Because its reference angle is 45. All the coterminal angles have that same reference angle, right? So that's what they do here is what are the trig function values of 210 degrees? Well, you find the reference angle is 30 degrees, so you can just bring in the side lengths of a 30, 60, 90 triangle, but just put the signs, like you can put negative y here, negative x here, and there you go, and do SOHCAHTOA. Okay, so here they just give the general steps for finding trig function values for any non-quadrantal angle. So if the angle is greater than 360 or less than 0, then find the coterminal angle, because you want to obtain an angle that's greater than 0 but less than 360. Then find the reference angle of that. Then find the trigonometric function values for the reference angle, and then determine the correct signs for the values found in step 3. Yeah, so what they're saying, when you do this, what they're pretty much saying here is that if you can find the trigonometric function values for the reference angle, then what you can do is you can go and label the side lengths of the triangle, the right triangle. That we talk about how you draw the right triangle. if you can determine the trig function values for the reference angle, then you could put the side lengths for that right triangle, but you put the right sign on it depending on the quadrant you're in, then do SOHCAHTOA on the reference angle. That's the idea. But, you know, again, we can't, if you think about it, if the reference angle isn't 30, 45, or 60, there's nothing we can do. We haven't talked about how to find trig function values of anything other than 30, 60, or 45 degree angles up to this point, or for other angles that have those as reference angles. So we're going to talk about this in more detail in the next section. Okay, so it says here, to avoid sign errors when finding the trigonometric function values of an angle, sketch it in standard position and include a reference triangle complete with appropriate values. Exactly. To me, it's good practice to always draw out that full triangle and put the side lengths with the correct signs, and then do SOHCAHTOA on the reference angle. Okay, so here's some more practice, just finding trig function values of these angles are going to have reference angles 30, 60, or 45. And I think I've given you the general idea of how to do this, but we're going to work a bunch of example problems in the next video. Okay, just here's more example problems. We're going to work a bunch of these in the next video. Okay, now here, what they're wanting to do is they're wanting to introduce the idea of if we have a trig function value and we want to determine the angle that trig function value corresponds to. So it's like we're going in the opposite direction. It's like it's an inverse. The idea of the inverse of a trig function. And we're going to go into full detail on inverses of trig functions in a later chapter, but in this section and the next section, we're going to kind of dip our toes into it a little bit. So here they're just starting with, we're thinking about going in reverse with reference if we have a reference angle. So it says here, so if we have a trigonometric function value in an interval in which the angle must lie, how can we determine? So yeah, if you think about it, we're going to need to, so let's look at this example. If we have cosine of theta is equal to minus root 2 over 2, and the question is, what value of theta corresponds to this? Well, if you think about it, we're going to need to be given an interval like the theta is between 0 and 360. Why is that? Well, because let's say this was 30 degrees. Let's say if we plugged in cosine 30, we'd get minus root 2 over 2. Well, that's not going to be the case because acute angles have positive cosines. Let's say 135. Let's say cosine of 135, we plug that in, it equals minus root 2 over 2. Well, that's fine, but then we know that any angle that's coterminal with 135 is also going to have this same value. So you see how they need to specify an interval. So it's going to be between 0 and 360 is what they're saying. Okay, so how can we analyze this? Well, we can think about root 2 over 2. That's like 1 over root 2. If you rationalize 1 over root 2, you get root 2 over 2. So we can think about the 45, 45, 90 triangle. Remember those ratios? That was 1, 1, root 2, right? So the cosine of 45 is 1 over root 2. That's root 2 over 2. Okay. Well, but this is minus root 2 over 2. So what does that mean? We're thinking about cosine of some angle is minus root 2 over 2, which is like minus 1 over root 2. Well, okay, that's what we talked about in this section. That's what we've been talking about. Theta is not going to be 45 degrees because cosine of 45 is going to be root 2 over 2. But what it's going to be is it's going to be an angle that has a reference angle of 45 degrees, right? And what kind of angle would that be? Well, think about it. Think about an angle in quadrant 2. So that would be 135. So this is 135. That's the angle we're thinking about. Okay, the reference angle is 45. So what's the next step? Well, you put the side lengths of the triangle. Well, okay, we've got minus 1, 1, and root 2. Now we come to this angle, forget about what the reference angle is, and just do SOHCAHTOA. Well, what's cosine of theta? It's minus 1 over root 2. There you go. So cosine of 135 is minus root 2 over 2. Okay, is that it? Well, no, that's not it, because this angle, which would be, that's 225, that also has reference angle of 45, and the adjacent is also minus 1. Minus 1 root 2. So cosine of 225 also has a value of minus root 2 over 2. So the answer to this is there's two possibilities, 135 and 225. So the answer here is theta could be 135 or 225. But there's more values, but we're restricted to between 0 and 360. Okay, so let's work some example problems.